So this is case 3 of group number 2 of solvable groups of trigonometric integrals. So cases 1 and 2 are in another video. It was unintentionally cut off. So I think it was the internet connection, and that was the reason why I wasn't able to share my screen. There's an audio, but you cannot see the whiteboard. Okay, because of power interruption, and not power, internet connection interruption. So if m and n are both positive even integers, so the powers of cosine and sine are positive even integers. So for example, cosine of y raised to the power 4. So as you can see, there's no sign here. Okay, so we assume, or rather, we um, consider 0 as an even integer here. Okay, for this case, so if there's no sign function, then we can still apply in case number 3. So we transform this into a double angle trigonometric function so that we can easily apply the different integration formulas, okay, for trigonometric functions. So we are going to express, the given integrand in this form first. So it's cosine squared. So our given integrand is cosine raised to the power of 4. So we need to square it first so that the base will be cosine squared. Okay. Medyo lag gamay. So cosine squared, and then we're going to raise this to a power of 2 dy. So instead of writing cosine squared, so we write 1 half, no, plus 1 half cosine of 2 times the angle. So if the angle here is y, then we double it. So it becomes 2y. And then don't forget to square it, before integrating. So expand the binomial. So it's 1 half squared, or that's 1/4, no, plus 2 times 1 half times 1 half cosine 2y, or that's 2 times 1 half is 1 times 1 half cosine 2y is 1 half cosine 2y. And then plus the square of the second term. So 1 half squared, that's 1/4, and then cosine squared 2y. Quantity dy. So we can easily integrate 1/4 dy. Okay, then also for 1 half cosine 2y dy. So for the third term, it's cosine squared. So there is no direct formula for the integral of cosine squared. So we need to use case 3 one more time. Okay, because we can apply case 3, right? Because the integer, the exponent rather, is an even integer. Okay, if we transform it to sine lang, okay, sine squared using a Pythagorean identity, so there is no integration formula, no, for sine squared, direct integration formula for sine squared. So we'll express this as a double angle na form. So we'll transform this into 4y, no? 2y times 2. So with an angle of 4y. So we'll write the other terms first, and then we'll just integrate them later. So applying the same identity. So multiply that with 1 half plus 1 half cosine 2 times 2y. So 1 half, okay, plus 1 half cosine double the angle. So it's 2y, so it becomes 4y. Okay, dy. So let me replace this with a bracket instead of parentheses. So the inner grouping symbol is parentheses. So let's simplify first. We have 1/4, and 1/4 times 1 half, or 1/8, 1/4 plus 1/8 is 3/8. Okay, then plus 1/2 cosine 2y, and plus 1/4 times 1/2 cosine 4y, or that's 1/8 cosine 4y dy. All right, so we can now integrate each term. So integral of 3/8 dy is 3/8 y, right? Then we have our u here is 2y. Let u be 2y. So du is, okay, let me put it here to the right para more space. So u is 2y. So du is 2 dy. So we need a neutralizing factor 1/2. Okay, take note, this is not the neutralizing factor, ha? It's 1/2 times cosine 2y. So we'll evaluate the integral lang of cosine 2y. So we need a 1/2. So we need pa to multiply this 1/2 with another 1/2. And then for the third term, u is 4y. So du is 4 dy. So we need a neutralizing factor na 1/4. So plus, no, again, copy the 1/2 and then multiply it with the neutralizing factor. And then this can now be written in the form cosine of u, and the integral of cosine of u du is sine of u. So it would be sine of 2y. And for the last term, we have plus 1/8 times the neutralizing factor na 1/4. Okay. And then cosine of 4y's integral is sine of 4y. Okay, so sine of 4y, and then the plus c. So 3/8 y plus 1/4 sine 2y plus 1/32 sine of 4y plus c. So this is the integral of cosine y raised to the power of 4 k dy. So up next is group number 3. Okay, this is group number 2, case 3. Again, cases 1 and 2 are in a separate video.